Good day, Tomasians. In this episode of Earth Rangers, we'll be tackling about the object that we always see every day while playing at the field or strolling with our girlfriend or boyfriend around Lover's Lane. Rocks!
The way rocks are formed and transformed, which is also called the rock cycle, will thoroughly be discussed.
Different types of rocks. Igneous, sedimentary, and metamorphic will be described and differentiated one by one. Plus, we will be discussing the different resources that we can get from these rocks and minerals.
This episode will also discuss the environmental problems with regards to mining and the ways on how we, as Tomasians, can help raise awareness and act against mining activities that are damaging the environment.
Rocks are constantly forming, changing, and reforming. This phenomena, called as the rock cycle, allows us to see many of the interactions among the numerous components and processes of the Earth system. It helps us understand the origin of the different rock types and how they are connected. In addition, the rock cycle demonstrates that any rock type can be transformed into another type. Earth as a system is illustrated with most vividly when we examine the rock cycle. The rock cycle allows us to see many of the interactions among the numerous components and processes of the Earth system. It helps us understand the origins of igneous, sedimentary, and metamorphic rocks and how they are connected. In addition, the rock cycle demonstrates that any rock type, under the right circumstances, can be transformed into any other type.
Well, the rock cycle is actually different sets of processes that happen to rocks whereupon rocks may be formed, they may be transported, they may be eroded and changed to another form of rock, and then transported again, and then they are then returned to their original location and source where they can undergo the cycle again.
We begin our discussion of the rock cycle with molten rock, called magma, which forms by melting that occurs primarily within Earth's crust and upper mantle. Once formed, a magma body often rises toward the surface because it is less dense than the surrounding rock. Occasionally, magma reaches Earth's surface, where it erupts as lava. Eventually, molten rock cools and solidifies, a process called crystallization or solidification. Molten rock may solidify either beneath or surface of following or volcanic eruption at the surface. In either situation, the resulting rocks are called igneous rocks.
So these are rocks that are formed from the cooling and solidification of molten material, whether that is magma deep underground, which produces rocks with large crystals, the so-called plutonic rocks, or whether it is in the form of lava extruded in volcanic eruptions, which produces microcrystalline igneous rocks, which we then call volcanic rocks. Now, these igneous rocks, they may be transported upward. It may be through magma moving upwards. It may be through lava that's already been extruded. So once these rocks have been brought to the surface, then they can be subjected to weather and erosion.
If igneous rocks are exposed at the surface, they undergo weathering, in which the daily influences of the atmosphere slowly disintegrate and decompose rocks. The loose materials that result are often removed downslope by gravity and then picked up and transported by one or more erosional agents, running water, glacier, wind, or waves. Eventually, these particles and dissolved substances, called sediment, are deposited. Although most sediment ultimately comes to rest in the ocean, other sites of deposition include river floodplains, desert basins, lakes, inland seas, and sand dunes.
So once these rocks have been brought to the surface, then they can be subjected to weather and erosion, interaction with wind and air, interaction with water, interaction with other forces. It can be biological forces as well. And so these rocks, they may be chemically, physically weathered, they may be eroded, and in the process of the weather and erosion, so you have particles transported downstream, or you have the minerals being dissolved in water, and under ideal conditions, then you have the formation of sedimentary rocks. So these rock fragments start to come together, and then they may be compacted and cemented, or the minerals in solution that are dissolved in water may start to crystallize as the water evaporates and you have precipitation. Then you have the formation of sedimentary rocks, in river basins and in other areas.
Next, the sediments undergo lithification, a term meaning conversion into rock. Sediment is usually lithified into sedimentary rock when compacted by the weight of overlying materials or when cemented as per quality groundwater fills the pores with mineral matter. If the resulting sedimentary rock becomes deeply buried or is involved in the dynamics of mountain building, it will be subjected to great pressures and intense heat. The sedimentary rock may react to the changing environment by turning into the third rock type, metamorphic rock. If metamorphic rock is subjected to still higher temperatures, it may melt, creating magma, and the cycle begins again. Rocks do not necessarily go through the cycle in order just described. Other paths are also possible. For example, rather than being exposed to weathering and erosion at Earth's surface, igneous rocks may remain deeply buried. Eventually, these masses may be subjected to the strong compressional forces and high temperatures associated with mountain building. When this occurs, they are transformed directly into metamorphic rocks. In a similar manner, igneous rocks that form at depth can be uplifted, weathered, and turned into sedimentary rocks. Alternatively, igneous rocks may remain at depth, where the high temperatures and forces associated with mountain building may metamorphose, or even melt them. Over time, rocks may be transformed into any other rock type, or even into a different form of the original type. Rocks may take many paths through the rock cycle. Metamorphic and sedimentary rocks, as well as sediment, do not always remain buried. Rather, overlying layers may be eroded away, exposing the once buried rock. When this happens, the material is attacked by weathering processes and turned into new raw materials or for sedimentary rocks.
As the rock cycle commences, it produces different types of rocks that have different components, origin, and function. Igneous rocks form as magma or lava pools and crystallizes. Magma is molten rock that is most often generated by melting of rocks in the Earth's mantle, although melting of crustal rock generates some magma. Once formed, a magma body buoyantly rises towards the surface because it is less dense than the surrounding rocks. When magma reaches the surface, it is called lava. Sometimes lava is emitted as fountains produced when escaping gases propel molten rocks skyward. On other occasions, magma is explosively ejected from vents, producing a spectacular eruption such as the 1980 eruption of Mount St. Helens. However, most eruptions are not violent. Rather, volcanoes most often emit quiet outpourings of lava. When molten rock solidifies at the surface, the resulting igneous rocks are classified as extrusive or volcanic. Most magma loses its mobility before reaching Earth's surface and eventually crystallizes deep below the surface. Igneous rocks that form at depth are termed intrusive or plutonic. Intrusive igneous rocks remain at depth unless portions of the crust are uplifted and the overlying rocks are stripped away by erosion. Common igneous rocks are classified by their texture and mineral composition. The texture of an igneous rock is mainly a result of its cooling history, whereas its mineral composition is largely a result of the chemical makeup of the parent magma. Granitic or felsic rocks, or popularly known as granite, is a coarse-grained igneous rock that forms where large masses of magma slowly solidifies at depth. During episodes of mountain building, granite and released crystalline rocks may be uplifted in the process of weathering and erosion, stripping away the overlying crust. Rhyolite is the extrusive equivalent of granite, wherein it has the same chemical composition but different in texture. And likewise, is composed essentially of light-colored silicates. This fact accounts for its color, which is usually buff to pink.
or light gray. Rhyolite is fine-grained and frequently contains glass fragments and voids, indicating rapid cooling in a surface environment. Obsidian is a common type of natural gas that is similar in appearance to a dark chunk of manufactured glass. Although dark in color, obsidian usually has a brighter silica content and a chemical composition similar to that of light-colored igneous rocks. Andesitic or intermediate rocks, or popularly known as andesite, is a medium gray, fine-grained rock, typically of volcanic origin. Its name comes from South America's Andes Mountains, where numerous volcanoes are composed of this rock type. In addition, the volcanoes of the Cascade Range and many of the volcanic structures occupying the continental margins that surround the Pacific Ocean have an andesitic composition. Diorite, the intrusive equivalent of andesite, is a coarse-grained rock that resembles gray granite. However, it can be distinguished from granite because it contains little or no visible quartz crystals. It has a higher percentage of dark silicate minerals. Basaltic or mafic rocks, or popularly known as basalt, is the most common extrusive igneous rock. It is a very dark green to black, fine-grained volcanic rock composed primarily of pyroxene, olivine, and plagioclase feldspar. The rock cycle shows the origin of sedimentary rocks, wherein weathering begins to process. Next, gravity and erosional agents like running water, wind, waves, and glacial ice remove the products of weathering and carrying them to a new location, where they are deposited. Usually, the particles are broken down further during this transport phase. Following deposition, the sediment may become lithified or turn to rock. Commonly, compaction and cementation transform the sediment into solid sedimentary rock. The word sedimentary indicates the nature of these rocks, where it is derived from the Latin sedimento, which means settling, a reference to a solid material settling out of a fluid. Most sediment is deposited in this fashion. Weather debris is constantly being swept from bedrock and carried away by water, ice, or wind. Eventually, the material is deposited in lakes, river valleys, seas, and countless other places. The particles in the desert sand dune, the mud on the floor of a swamp, the gravels in a steam bed, and even household dust are examples of sediment produced by this never-ending process. Geologists estimate that sedimentary rocks account for only 5% of the volume of the Earth's outer 16 kilometers or 10 miles. However, the importance of this group of rocks is far greater than this percentage implies. If you sample the rocks exposed at the Earth's surface, you would find that the great majority are sedimentary. Indeed, about 75% of all rock outcrops on the continents are sedimentary. Therefore, we can think of sedimentary rocks as comprising a relatively thin and somewhat discontinuous layer in the uppermost portion of the crust. This makes sense because sediment accumulates at the surface. It is from sedimentary rocks that geologists reconstruct many details of the Earth's history, because sediments are deposited in a variety of different settings at the surface. The rock layers that they eventually form hold many clues to the past. Finally, many sedimentary rocks are important economically, like coal, which is burned to provide a significant portion of the Philippines' electrical energy, wherein it is classified as a sedimentary rock. Other major resources, such as petroleum and natural gas, occur in pores within sedimentary rocks. These sedimentary rocks are major sources of iron, aluminum, manganese, and fertilizer, plus numerous materials essential to the construction industry. Classifying sedimentary rocks. Materials that accumulate as sediment have two principal sources, wherein detrital sedimentary rocks are made of solid particles, mostly quartz, grains, and microscopic clay minerals. Common detrital sedimentary rocks include shale, which is the most abundant sedimentary rock, sandstone, and conglomerate. Chemical and biochemical sedimentary rocks are derived from mineral matter, which, or ions, that is carried in solution to lakes and seas. And under certain conditions, ions in solution precipitate wherein they settle out to form chemical sediments as a result of physical processes such as evaporation. The precipitation may also occur indirectly through life processes of water-dwelling organisms that form materials called biochemical sediments. Many water-dwelling animals and plants extract dissolved mineral matter to form shells and other hard parts. After organisms die, their skeletons may accumulate on the floor of a lake or an ocean. Coal, which is in contrast to sedimentary rocks that are rich in calcite or silica, consists mostly of organic matter. Close examination of a piece of coal under a microscope or magnifying glass often reveals plant structures such as leaves, bark, and wood that have been chemically altered but remain identifiable. This supports the conclusion that coal is the end product of the burial of large amounts of plant material over extended periods. Metamorphic rocks are produced from pre-existing igneous, sedimentary, or even other metamorphic rocks. Thus, every metamorphic rock has a parent rock, the rock from which it was formed. Metamorphism, which means to change form, is a process that leads to changes in the mineralogy, texture, for example, is grain size, and sometimes chemical composition of rocks. Metamorphism takes place when pre-existing rock or rocks is subjected to a physical or chemical environment that is significantly different from that in which it initially formed. In response to these new conditions, the rock gradually changes until a state of equilibrium with the new environment is reached. Most metamorphic changes occur at the elevated temperatures and pressures that exist in the zone beginning a few kilometers below the Earth's surface and extending into the mantle. Common metamorphic rock. Foliated rock. Slate is a very fine-grained foliated rock composed of minute mica flakes that are too small to be visible. A noteworthy characteristic of slate is its excellent rock cleavage or tendency to break into flat slabs. This property has made slate a useful rock for roof and floor tile, as well as billiard tables. Slate is usually generated by the low-grade metamorphism of shale. Less frequently, it is produced when volcanic ash is metamorphosed. Slate's color is variable. Black slate contains organic material, red slate gets its color from iron oxide, and green slate is usually composed of chloride, a greenish mica-like mineral. Phyllite represents the degree of metamorphism between slate and schist. Its constituent platy minerals, mainly muscovite and chloride, are larger than those in slate but not large enough to be readily identifiable with the unaided eye. Although phyllite appears similar to slate, it can be easily distinguished from slate by its glossy sheen and wavy surface. Schists are moderately to strongly foliated rocks formed by regional metamorphism. They are platy and can be readily split into thin flakes or slabs. Many schists originate from shale parent rock, and the term schist describes the texture of a rock regardless of its composition. For example, schists composed primarily of muscovite and biotite are called mica-schists. Gneisses is a term applied to banded metamorphic rocks in which elongated and granular, as opposed to platy, wherein these elongated and granular minerals predominate. The most common minerals in gneisses are quartz and feldspar, with lesser amounts of muscovite, biotite, and hornblende. Gneisses exhibit strong segregation of light and dark silicates, giving them a characteristic banded texture. While still deep below the surface where temperatures and pressures are great, banded gneisses can be deformed into intricate folds. Non-foliated rocks. Marble is a coarse, crystalline rock whose parent rock is limestone, and marble is composed of large interlocking calcite crystals which form from the recrystallization of smaller grains in the parent rock. Because of its color and relative softness, marble is a popular building stone, while white marble is particularly prized as a stone from which to carve monuments and statues, such as the Lincoln Memorial in Washington, D.C. and the Taj Mahal in India. The parent rocks from which various marbles form contain impurities that color the stone. Thus, marble can be pink, gray, green, or even black. Quartzite is a very hard metamorphic rock most often formed from quartz stones. Under moderate to high-grade metamorphism, the quartz grains in sandstone fuse. The pure quartz size is white, but iron oxide may produce reddish or pinkish stains, and dark minerals may impart a gray color.
Some of the most important accumulations of metals, including gold, silver, copper, platinum, and nickel, are produced by igneous and metamorphic processes that concentrate desirable materials to the extent that extraction is economically feasible. In the Philippines, metals such as gold, copper, iron, and nickel are abundant and has been an important commodity in the market. The country has been considered as a top exporter of such materials, especially nickel. Mineral resources not used as fuels or processed for the metals they contain are referred to as non-metallic mineral resources. These materials are extracted and processed either to make use of the non-metallic elements they contain or for the physical and chemical properties they possess. Non-metallic mineral resources are commonly divided into two broad groups: building materials and industrial minerals. Coal, petroleum, and natural gas are the primary fuels of our modern industrial economy. Currently, about 82% of the energy consumed in the United States comes from these basic fossil fuels. Coal, in addition to oil and natural gas, coal is commonly called a fossil fuel. This designation is appropriate because when coal is burned, energy from the sun that was stored by plants many million years ago is being used, hence the actual burning of fossils. Together, petroleum and natural gas provide more than 60% of the energy consumed in the United States in 2012. Like coal, petroleum and natural gas are biological products derived from the remains of organisms. However, the environments in which they form are very different, as are the organisms. Coal is formed mostly from plant material that accumulated in swampy environments on land. Oil and natural gas are generated from the remains of marine plants and animals, mainly microscopic plankton, which died in ancient seas millions of years ago. This organic material was deposited in sedimentary basins together with mud, sand, and other sediments that protected it from oxidation. With increased temperature and burial, chemical reactions gradually transformed this organic matter into liquid and gaseous hydrocarbons we call petroleum and natural gas.
In order to acquire metallic, non-metallic, and energy resources, private companies would engage in mining, which has been an important source of income, especially in the Philippines. However, environmental problems with regards to mining activities has been seen, as it requires the total alteration of its environment, which will endanger many communities living around the vicinity. Trees will be cut from mountains to give way for mines, which will result to flash floods coming from the mountains. Risks of contamination due to irresponsible disposal of mining waste, such as mercury, are high, which can lead to widespread sickness in affected communities, such as in the case in Marinduque in 1996, where a Canadian-owned mining company contaminated rivers with tailings, which led to widespread sickness. Some mining companies has been violating environmental regulations, and the Department of Environment and Natural Resources, under the leadership of Secretary Gina Lopez, has conducted an audit on mining companies and has been suspended 10 mines, 8 of which are nickel mines.
Wherever there's mining, the people are poor. It's not good at all. Okay, so the mining companies have to get their act together.
Our citizens, and as commercials, we can do something in order to alleviate or to prevent further environmental degradation. Because here are the plan of action that we can recommend with regards to the topic.
One practical method for going about limiting the illegal mining that is going on in the Philippines that students can achieve is petition. Petition, though seemingly insignificant, can actually put a great notice out to the government and to the common people about the harmful effects of illegal mining and improper mining techniques utilized here in the Philippines.
The main problem in the Philippines in illegal mining is that the problem of illegal mining here in the Philippines is that when laws are made by the government for the conservation of the environment and its minerals, most of these laws are not well implemented or given importance to. That is why we think, as the mining rangers, thought of a way to decrease or minimize these illegal mining firms in the Philippines by boycotting the products made by these illegal mining firms. Thus, the products made through mining are equally as important as the natural things we need for our daily lives in today's time. And these products are sometimes more important than the food that we intake or the water that we drink.
Movement such as nationwide protests could pave the way for an alarming impact to the government, to target being the headline in the newspaper, resulting for the awareness of the other foreign country, consequently to warn our government to focus on this issue. Also, protests can be seen as a symbol of solidarity for the activists and participants in their aim of demonstrating their work of the environment. This movement will aim to have a massive and impulsive impact in provoking of having a more central emphasis and the real definition of their argument and serious concerns.
With the another plan of action that we can do is to raise awareness through social media. As we all know, many people are now using social media sites such as Facebook, Twitter, and Instagram. By using the social media and helping to raise awareness with regards to the plight of many people and the destruction that was caused by mining, many people will be aware of what is happening and can call for the government to act in order to prevent further damage to the environment.
Hi, I'm Miles.
Hi, I'm Emmanuel.
Hi, I'm Dennis.
And I'm Dimitri.
And we are the Earth Rangers!